This video is about Python decorators. Decorators are a more advanced topic, one of the more complex conceptually among topics in an intermediate or advanced Python course. And that's because we need to draw together a number of concepts into a whole. It begins with the idea of object references. A reference is an address, basically, to an object which is stored in memory. And when we look at object references, we're back to the concept that a name points to an object. And when we think of the object, we should think about it as being in memory. It's sitting in memory on a memory board, and the name has an address that points to where that, or it uses the address to point to that object. And that multiple variables, even if one is assigned to another, are really simply both using the same address to get to the object. That's the first concept. The second concept is the one that you can pass a function as if it were an object, because indeed a function is an object. That's the second concept. A function is an object. It's just like an integer or a string or a list. It may behave differently. It may seem very different since a function is really a series of statements, but we should think of a function as being data. And as such, it is an object in Python, an object of type function. And when we define a function, we are actually defining an object, which is a value, and we're assigning a name to it. So call it is a name that is pointing to a function object, and greet is a name that's pointing to a function object. Now in this exercise, we're asked to call greet through arg, and we can do so. This is an example of us passing an object, a function object, to another function. And this is, as we said previously, something we call a higher order function. In other words, when I say call it and I pass it greet, the first thing to note is that I'm not calling greet. I'm not calling greet through the name greet. I'm actually just passing a reference to a function object. In the same way that I can say greet equals a reference to a function object. Again, this function object is stored in memory, and the name points to the object. These are the concepts that we had before. Then the idea that a function is also an object. And so, since we're passing the name greet to this function call it, we're saying that arg should be equal to greet. And since we know that greet is pointing to a function object, we also know that arg is pointing to a function object, the same function object. And thus, we should be able to call greet through arg. We should see hello world here. I'm going to make a change here. Now, with just we see hello world, we can't really know whether greet was called directly or through arg. But here you can see there's no part of the code that's actually calling greet. It's not being called here. I'll just go ahead and comment this out, maybe put pass here, and not call greet, and you'll see we won't see anything. Whoops, I ran the debugger. Let's do it again. You can see I'm not getting anything if I comment out the call to arg, but if I take that comment off again, I'm calling greet through arg. By the same token, take a look at this madness. What am I returning from return it? I'm calling return it, fine. We go up to return it, and then what am I returning if I'm returning greet? What is greet? Again, I'm not calling greet. I'm just returning greet. What is greet? Well, you can see that greet is defined as a function. This is probably the first case in which you've seen a function defined inside another function. Something we call a nested function or a local function. In this case, we're returning the function greet. which was stored in memory on the memory board, and assigned a name greet. So we're returning not really greet, we're returning a reference to that function. Again, don't forget, the memory location and the name are in different locations. They're different places. The function is stored in memory, and there's a name pointing to it, greet. And so we can say that when we say x equals return it, we're really saying x equals greet. And if that's the case, then it should be obvious, or maybe not, that if we call x, we're going to be calling greet. Let's try it. There it is. We're calling greet through x. Now, oftentimes I get a question, if greet was local, because greet is local, right? We know that. We know that any variable that's defined inside a function is only available inside the function. But that was never really true. For example, just from what we've said before about local variables, that if I say x equals, or if I say yy equals 5, that I won't be able to print yy here. What will I get? I'll get a name error. And that sort of implies that the value 5 is now gone. And that would actually be true in this case because only one variable name pointed to 5. And when we're done with the function, that variable name loses its assignment. It's a local variable, right? We know this from earlier discussions of functions, that any variable defined inside the function is local to that function. But keep in mind that what's local is not the value necessarily. What's local is the name. That's why when we print yy, we get a name error. Can't find that name. That name does not exist anymore. We know why it doesn't exist. But sometimes I get the question, well, if greet is also local, then how could it be called outside the function? And the answer is that it's not that the object itself is local. It's that the name is local. The name greet is local. Greet doesn't exist anymore. It's true, and we'll get a name error here. But the function itself, because we returned a reference to that function and then assigned that reference to x, we actually have the function still existing, and it's being pointed to by a global variable x. And that's why we can call it. So this is the inverse of what we saw earlier, which was that you can pass a function to another function and call it in that function. This would be the reverse. You can return a function from a function and call it. Again, if any of this is at all confusing, you want to consider reviewing as many times as is necessary to try to fully understand what we're talking about here. To be able to say return greet and understand that greet is a function and thus x is pointing at a function. Or I should say greet is pointing at a function and thus x is pointing at a function. The function that was pointed to by greet, and thus we should be able to call it. That's one of the understandings to keep in mind. Same thing here. You have a function that's defined called greet, and you pass greet to call it, and now arg points to that function. Keeping in mind constantly, first, the idea that all objects are assigned by reference, meaning that we're actually assigning a memory address to a name when we create a variable. And then secondly, that functions are objects. So they do the exact same thing, or they have the same dynamics as any other object, that they are assigned by reference to a name, and that you can reassign that name to another name. You're assigning that reference, that address, to the object. And it's only when you call the object through the name that the actual function gets called. Okay, now we're going to take it one step further. And we're going to look at something that we could call a decorator, even though it is not yet, strictly speaking, a decorator. We can call it that. I'm going to get rid of a couple of blank lines here because we're running out of space here. Let's do this. I kind of want to make sure, yeah, that we have certain things going on here. Oh, looks like I'm going to have to do more. Okay. Now, what I would do is pause the video and take a good hard look at this, because this really is not necessarily intuitive, but it's making use of all of the concepts that we've brought up so far. And this is all in service of understanding decorators. All in service of understanding that functions are passed by reference and that it's possible to pass a function to or from another function. It's going to help enable the advanced concept of a decorator and a very useful tool when designing more advanced level programs. Take a look at this code, and before you run it, ask yourself what we're likely to see if we were to run it. And if I were you, I would pause and stare at this for as long as necessary for you to at least have maybe an idea, or to the point where you might give up. That's okay too. Just keep in mind that we are both passing functions to other functions, and we are also returning a function from a function. See if you can keep that in mind as you look at this and try to decide what you're going to see if you run this code. Okay, let's take this step by step so that we can reinforce those same ideas and remember some of them as we try to understand what this code is doing. We begin after the two function definitions, which, are fine. We've defined some functions. We know that they're going to do what they do when we call them. But let's not go into them just yet. When I read code, I generally like to start with the first call, or the first main body code that isn't just a definition, because that's sort of where the action begins. In this first step on line 20, we're calling my decorator, and we're passing it this function. So the question you need to ask is, if we're passing it this function, what is this function? What is the object type of this function? Now you can see that this function is defined on line 16. Great. So we can do the same notation that I've done in the past. I think it's actually quite useful. And that's to say that my func equals this function. This can be really challenging to understand, so it would really behoove you to take as many notes and write as many illustrations as you can so that you can try to understand in the spirit of notations, which is supposed to, help. Now that we understand that my func is pointing to this function, that's what my func is, right? It's been assigned a reference to that function, so that if we were to call my func, it would call this function. Now we see another definition here, wrapper. And wrapper is defined inside my decorator, similar to what we saw previously. Wrapper isn't being called yet. That's something to understand. When you see a definition, that definition is simply defining what will happen if you call it. So when you're reading your code, it's sometimes useful to look at the function at the point at which it's being called. Let's just look at wrapper as a function that was defined. We're not going to think too much about what's happening with the function, but we will when we get to calling it. And let's look at what happens at the end here. I'm sorry, this is the function. I had highlighted one more line that's actually there. This is why I like to have a space here. We're returning wrapper. And so you want to ask if the function my decorator is designed to take a function as argument, then define another function, wrapper, and then return wrapper. What is wrapper? What is the type of wrapper? Well, wrapper is a function, is it not? Okay. We can now do that notation again. This function equals wrapper. Okay? So now we know that this function is the wrapper function. It's the same one. Now we haven't looked at what wrapper does yet, but let's keep in mind that it's a function, and then when we get ready to call it, we're going to go look at it and see, and that should tell us what we'll see when we run this code. So now we call this function. Now, what is this function? Well, we just defined it. This function is wrapper. Okay, well, if this function is wrapper, then what happens when we call this function? Let's take a look. This function wrapper will print something is happening, and then it will call myfunc. Now we have to go back and remember what myfunc is. What is myfunc? Myfunc is this function. So at this point, we're printing whe. Wrapper begins by printing something is happening before, then it prints whe, then it prints something is happening after. That's how this works. When we call this function, we're actually calling wrapper. But wrapper calls myfunc, and myfunc is this function. Wait a second. I thought we just said that this function is wrapper. Okay, well, we could maybe begin by saying this function 2 equals. All right, what's going to happen when we call this function 2? Well, we have to ask what that is. It is wrapper. Okay, what does wrapper do when we call it? It prints something is happening before. It calls myfunc. But wait, what is myfunc? Myfunc is this function. Oh, okay, so it prints whe. Then it's going to print something is happening after. Okay, something is happening before, whe, something is happening after. Let's see. And there it is. Something's happening before, whe, something is happening after. Now, what did that get us? I mean, what are we getting here? And in fact, what would it mean to say this function equals? Well, I want to clue you in to what a decorator does now. What a decorator does is it supplies a replacement function. It supplies a replacement function to replace a given function. But that replacement function is usually designed to augment what the original function did. I'll say it again. The replacement function that's provided by a decorator is designed to augment an existing function. So what would happen if I called this function and before it was decorated? What do I see? I see whe, right? That's what this function does. Simple little thing. It prints whe. Great. But what happens when we call this function after it was decorated? We're going to see something's happening before, whe, something's happening after. In other words, in this simple example, we have augmented the functionality of this function. And that's actually why we gave it the same name as the original. We have replaced that original function, but the replacement function does what the original function did and more. The replacement function does what the original function did and more. That's the idea of a decorator. A decorator replaces a function with a new and better function, a function that adds functionality. So why would we use this? Well, there are many reasons we might use this. We would use it anytime we want to take any function that we know and replace it with something that does a little bit more. Let's say we want to log what happens when we call the function. We want to make sure that it's in the right currency, and so it's going to process the value a little further. Maybe there are a bunch of monetary functions that we use that work in dollars, but if you use the euro decorator, it'll convert all those values to euros automatically. That's what a decorator does. A little bit difficult, really, to explain exactly why this would be so useful, but we will see a little bit more in part 2.